Hello everybody. Now we're going to start practice set number 2.3 from Maharashtra State Board textbook from Mathematics Standard 10th. Now question is solve the following quadratic equation by completing square method. So this is only question in this exercise which we need to solve. We will take these two questions. This question number 1 I am going to solve and this question number 4. Because as far as completing square method is concerned, you will find two types of question. One, this type, this question number 1, and the other type is like question number 4. So as you can see, this question number 1, question number 2, question number 3, all three questions are same. The method to solve these three questions will be same, because what is common in these three questions, the coefficient of first term, that is a, is 1 in all these three questions. But if you observe question number 4, 5 and 6, these questions are little bit differ from first three questions, because here coefficient of first term is more than or less than 1. So in this question coefficient of first term is 9. In this question coefficient of first term is 2. In this question coefficient of first term is 5. So we can divide the method to solve all six questions in two groups. One type is of those question where the coefficient of first term is 1, and the other type of solution is consist of those question where the coefficient of first term is uh, more than or less than 1. Now, so I am taking these two questions. Question number 1. So this is my question number 1. X square plus x minus 20 is 0. So what I'll do, first I'll comparing the given equation with standard form, comparing with standard form, and standard form is ax square plus bx plus c equals to 0. If your question is in this form, then you can write it as ax square plus bx plus b by 2 whole square minus b by 2 whole square plus c equals to 0. If you observe this standard form and this new form in which we are writing, both are one and same. The only difference you will find is b by 2 whole square, b by 2 whole square. So once we are adding this b by 2 whole square and once we are subtracting b by 2 whole square from same equation, so these two will not make any difference in the original value of the equation, because if you adding and subtracting same value from the from any equation, the equation will remain same. It's like this. Suppose you have 5, in that you adding 2 and you subtracting 2, so same value is added and same value is subtracted, so the value will remain as 5. So same way in this equation I am adding b by 2 whole square and I am subtracting b by 2 whole square, so it will remain same. The value of this equation will not change. So my equation is in this way, in this form. I am going to write it in this form. But before that we need b by 2 whole square. What is value of b by 2 whole square? So I'll find out b by 2 whole square first. B, that is coefficient of second term. So here we have second term whose coefficient is 1. So I'll take 1 by 2 whole square. So 1 by 2 whole square will become 1 by 4. So this is b by 2 whole square. Now I'm going to take this 1 by 4. Once I'll add and subtract in my original equation. So my original equation can be written as x squared plus x plus 1 by 4 minus 1 by 4, and last term, that is c, will remain same, which is 20 in our case. So this is um, so I'll write this 20 within the bracket because here we have minus 20, right, equals to 0. Now these three can be paired together. First three can be paired together as x square plus x plus 1 by 4 in one pair. This is minus, so I'll take minus, since this minus plus will give you minus. So it is 1 by 4. Since I'm taking minus and these two are together minus, so here you will get plus 20 equals to 0. Now this is x square plus x plus 1 by 4. So I can write it as write down this in the form of a plus b the whole square. So in order to write this in the form of a plus b the whole square, you just need to take square root of first term. So this is your first term. So I'll take x, this is x square. So square root of x square is x plus this is your third term. So I'll take square root of third term, that is 1 by 2 whole square. So this turn into a plus b the whole square. Now minus, within the bracket you can solve this part. So this will become 1 plus 4 into 20 will give you 80 by 4 is equals to 0. So here we have x plus 1 by 2 whole square minus 81 upon 4 is equals to 0, right? Now further I can transpose this 81 by 4 to the right hand side. So it will look like this: x plus 1 by 2 whole square is equals to negative 81 by 4 will become positive 81 by 4 when you bring it to the right hand side. So you can take square root of both the sides. So it will become x plus 1 by 2 is equals to, now the square root of 81 by 4 will become plus minus 9 by 2. Why plus minus 9 by 2? Because minus 2 into minus 2 is equals to plus 4, as well 2 into 2 is also equals to 4. Since 4 is the square, which is the square of negative 2 as well as positive 2. So whenever we are taking square root of a number, it can be a positive one or it can be a negative one. Now this is not part of our solution. So therefore, keeping x on its place, this 1 by 2 can be transposed to the right hand side. So this is positive 1 by 2 will become negative 1 by 2. And here we have plus minus 9 by 2. So this way x will have two values: minus 1 by 2 plus 9 by 2, or x can be minus 1 by 2 minus 9 by 2. So when you simplify, you will have two roots of this equation as minus 1 plus 9 upon 2, right? Or x equals to minus 1 minus 9 upon 2. So this way x is equals to minus 1 minus 9, that is 8 upon 2, which is equals to 4, or x equals to minus 1 minus 9, that is minus 10 upon 2, which is equals to minus 5. So minus 5 and 4 are the roots of the given equation. Now it's time to solve this question number 2. So I'm going to copy this question number 2 on new sheet so that we can solve this question properly. Again, we will use completing square method to solve this equation. Equation is 9y square minus 12y plus 2 equals to 0. The only difference between these two questions is, in previous question the coefficient of first term was 1, but here the coefficient of first term is 9y square. So we need to convert this 9 into 1. So what can I do? Simply we can divide this equation by 9. So dividing by 9, you will get y square minus 12 upon 9. Look, here we have 9. So I am dividing by 9. So 9 upon 9, y square minus 12 upon 9 into y, and plus 2 upon 9 equals to 0 upon 9. Each and every term is divided by 9. So here you can write dividing by 9. Now after dividing by 9, you can just write this equation in proper way. So 9 will cancel. You will have only y square minus 12 upon 9 can be written as 4 by 3 y plus 2 by 9 equals to 0 upon 9, that is 0. Now this is new equation. So this is your ax square plus bx plus c equals to 0. Now this equation is in proper standard form. So again, what we will do? We will make comparison. Comparing with ax square plus bx plus c equals to 0. Then you can write this equation as ax square plus bx plus c b by 2 whole square minus b by 2 whole square plus c equals to 0. So this equation can be written in this way, like this. Y square. So before writing this equation in this form, we need b by 2 whole square. So first I'll find out value of b by 2 whole square. Here coefficient of middle term is minus 4 by 3 upon 2, that is 1 by 2 whole square. 2 ones are 2 twos are 2 ones are 2 twos are. So this will give me minus 2 upon 3 whole square, that is 4 by 9. This is my third term. This is my new term, that is b by 2 whole square. What I can do, I can add this b by 2 whole square in my original equation. Once I'll add and once I'll subtract. So this can be written as y square minus 4 by 3 y plus 4 by 9, that is b by 2 whole square, minus 4 by 9 b by 2 whole square plus c plus 2 by 9. is equals to 0. Now first three terms can be taken together. So it will become y square minus 4 by 3 y plus 4 by 9, and the other is 4 by 9. Since I am taking minus as a common factor, so this plus will change to minus 2 by 9 equals to 0. Now I can convert this part as a minus b the whole square. So here you can say, you can take square root of first term, that is y, minus 4 by 9, that is 2 by 3 whole square, minus 4 minus 2, that is 2 by 9 equals to 0. So this is negative 2 by 9. So this can be written as y minus 2 by 3 whole square is equals to positive 2 by 9. Look, this negative 2 by 9 is taken to the right hand side. So it will become positive 2 by 9. Now taking square root of both the sides. So this side will become y minus 2 by 3. Since 2 is not a perfect square, so I'll take square root of 2 because I'm taking square root of both the sides. And since this 9 is perfect square and its a square root is 3, so simply you can write 3. But remember, whenever you're taking square root, there are two possibilities, either positive or negative. So the square root of 2 by 9 can be plus root 2 by 3, or it can be minus root 2 by 3. Now, therefore, keeping y on its place, this negative 2 by 3 can be transposed to the right hand side, will become positive 2 by 3. Here we have plus minus 2 root 2 by 3. So therefore y equals to 2 plus root 2 upon 3, or we can say y equals to 2 minus root 2 upon 3. Now as we know, this 2 has root 2, so I can take out root 2 as a common factor in order to further simplify them, or you can leave your answer here only, where this is your final answer, that is 2 plus root 2 upon 3 and 2 minus root 2 upon 3. So these are two roots of the equation. So here you can say therefore 2 plus root 2 upon 3 and 2 minus root 2 upon 3 are the roots of the given equation. So this is the way to solve this any quadratic equation by completing square method. Now let me explain the difference between why we need this method. Before this we have studied how to solve quadratic equation. In previous tutorial we have already discussed about this, how to solve quadratic equation by completing square method, and in this tutorial we are learning how to solve quadratic equation by completing square method. As far as we remember, in order to solve any quadratic equation by splitting middle term, the equation need some special arrangement, where we need to find out uh, two linear factors of the third term whose sum should be same as middle term, coefficient of the middle term, which is a which is a condition which has to be fulfilled in order to solve any quadratic equation by completing square method, and that is not possible in case of all the quadratic equations. So that's why we need some other methods which can be applied on any quadratic equation in order to find the square root of those equation. So here uh, we are doing completing square method, and this completing square method can be used to find the roots of any quadratic equation, but splitting middle term cannot be applied on all the quadratic equations. We will study uh, another method, that is formula method, to find the square root of the quadratic find the roots of the quadratic equation by using quadratic formula in our next tutorial. Thank you.